Okay, I'm going to go ahead and get started now. Welcome everybody to today's webinar. It is about winter concerns, mostly ice damming, but other winter concerns as well for buildings. So generally what I'll be talking about, we're going to go through roofs, which is mainly what's affected by winter weather in buildings. Parts of the roofs, how they work, winter problems associated with roofs. There'll be a CEU keyword thrown in there, and also then we'll talk about the causes of ice damming, symptoms and solutions for ice damming. So just relatively briefly, I'm going to go through the various parts of a typical building roof. You can see the little diagram here on the screen. A lot of different parts to a roof. Not all roofs, but quite a few different buildings have a lot of these parts as making up the structure of their roof. The main part of a roof is at the bottom of it is the eave. At the top of the section is the ridge. If you have the roof elevation changing, then you have a gable end, and the edge of that at the roof line is called a gable or a rake. The wall is the sidewall. At where the lower roof and the upper roof meet, there is flashing installed there. It's called step flashing that keeps water from penetrating at that location. You can also have dormers, chimneys, various things. And then you can also have at the lower left there, you see a flat roof that intersects a vertical wall. And that would also be an area for potential water infiltration. So the vulnerable areas are anywhere where there's a penetration or an intersection of two roof lines. And those are some of the areas that we're going to be talking about. Other areas that can allow leaking in the wintertime, particularly, are valleys where snow and ice can accumulate, and the areas behind chimneys, which can allow snow to accumulate behind it. So generally speaking, we're going to be talking about two kinds of roofing, mostly shingle roofs. Low slope roofs, or what's commonly called a flat roof, usually have a membrane roofing material, but they're not as vulnerable to ice damming and other problems, winter problems. So we're going to concentrate mostly on shingle roofs. Thing to consider is these roofs, shingles, are not waterproof. They're water resistant, and they rely on the slope of the roof and gravity bringing the water down the roof slope to be shed off the edge of the roof, either right off the edge directly or into a gutter and downspout system to drain the water. It relies on the shingles overlapping each other and also sealing to each other. You can see in the diagram here, there's a line of it almost looks like a dashed line, and that is sealant. And what happens is once the shingles are installed and the sun gets on them, that sealant will melt, and the shingle above that one seals to the lower shingle, and it works its way all the way up the roof. And the other thing that shingle roofs use an underlayment. That's usually either tar paper, what's called tar paper, or asphalt roofing felt, or a membrane material, which is commonly referred to as ice and water shield, which would be put on the roof deck, either the plywood, or in the case of this photo, it's OSB board. There's also a drip edge on the edges of the roof to help secure down the underlayment and prevent water from getting in at those locations. So I talked about earlier where a roof intersects a sidewall. That's in the upper photo. You'll see that typically, or always, you would need to put flashing there. And the flashing would prevent the water from penetrating at that intersection and getting underneath the roof sheathing and behind the sidewall. Flashing is typically typically metal, but it also can be a membrane or a plastic material. Very critical because as the water runs down the roof, the flashing prevents it from penetrating and directs it down the roof and into the gutter or off the edge of the roof. Typically, you install flashing, as I said, on a sidewall where a roof intersects a front vertical wall and other areas where water penetration can be an issue. Obviously, without this flashing, the roof will leak. The lower photo, you can actually see the metal pieces, and they're called step flashing because they're overlapped almost like steps, and interlapped with the shingles themselves. So it's an L-shaped piece of material that goes under the shingle and then up the sidewall and seals off the intersection. The piece of white material in the lower photo is called the kick-out flashing. It's a piece of step flashing that's shaped differently, and it's bent at the bottom to direct water into the gutter that you can see in the photo, rather than allowing it to run down the wall below the gutter. And that's pretty critical in keeping water from penetrating below this roof line. And the lack of the lack of kick-out flashing definitely causes a lot of issues with water penetration on that vertical wall. Here's a detail of why it's important to have flashing, but it's also important to have the flashing installed properly. And on the left, that detail you'll see shows the proper way to install the flashing. You have the house wrap. If I go back to the previous slide, you don't really see house wrap, but there would be a Tyvek or another house wrap coming down the wall. That should overlap the top of the flashing and counter flashing, so that moisture that gets behind the siding runs down the house wrap and sheds off of it and out onto the roof and off the roof. On the right-hand slide, the house wrap runs behind the flashing, so any water running down the house wrap gets behind the flashing and negates the effect of the flashing and allows penetration. As I said earlier, two general types of flashing: sheet metal flashing, which is by far the most commonly used material. It can be various materials: steel, zinc, aluminum is the most common. You can also have copper flashing, not used very much anymore because it's much more expensive than the other types. And then you have a rubber or plastic flashing material. It's cheaper to install, cheaper to buy. However, it doesn't last as long. And it also, if any of it's exposed to the sun, it'll degrade from the UV radiation. And as I was speaking about earlier, most roofs, or many roofs, have gutters and downspouts installed to collect the water running off the roof and divert it and direct it to an area to keep it from causing any problems with the foundation of the building with water accumulating there, and also to direct it away from the roof itself to prevent leaks there. The gutters and downspouts are specified in the building code as far as sizing, based on the amount of local rainfall and the area of the roof that's being drained. Another critical area is roofs, buildings that have attic spaces. And this is a critical area with regard to ice damming in particular. Attic is the area above the top floor ceiling of a building and below the roof. Can be a larger area like you see in this photo, or a very small area with very little space. One of the things with an attic is it helps to control the temperatures in the house by having it properly ventilated. You direct away, particularly in the summertime, a lot of the heat that builds up on a roof. Also, some attics are designed for storage. In this particular case, it looks like you might, because the ceiling joists appear to be 2x6 or maybe even 2x8. You could probably store in this attic. A lot of attics today, in fact, most attics today that use where the roofs are constructed with prefabricated trusses, are not designed to have any storage in them. They're only designed to support the roof above. And so you have to be careful with storing in attics that don't have the proper structure to allow it. All right, attic insulation. Obviously, most attics, all attics, buildings are insulated. Obviously, the attic, you get a lot of heat loss from the living space below it, and particularly in the winter, and the insulation keeps the heat inside the living space and reduces it in the attic space. As you try to reduce that as much as possible by having enough insulation. Then the other component of attic space is ventilation. You need to have proper ventilation in the attic in order to have the warm air or cooler air in the winter, exhausted, and keep the space comfortable. Typically, warm air, rises, so attics will accumulate whatever heat loss they get, and also in the summertime, the heat from the sun. And you want to have intakes at the lower part of the roof to allow cooler air to enter, and the venting at, the ventilation exhausts at the top part of the roof to allow that warm and humid air to escape. Another important thing in preventing ice damming or minimizing ice damming, and also just generally for the health of the attic space, is any fans in the living space, either bathroom or kitchen exhausts, need to be vented directly to the outside so that the warm, moist air coming out of either a kitchen or bathroom will not accumulate in the attic and cause problems with deterioration. That also would go for dryer vents for clothes dryers if they're vented through the attic space. Now, you also have homes with cathedral ceilings, and it's essentially the same concept as a larger attic space. You have to, insulate it. and vent it. The issues with cathedral ceilings are a little bit more complicated because the space limitations between the ceiling of the living space and the roof, there's not much space, so it's more difficult, particularly with ventilation, to make sure you have adequate ventilation through there. In a lot of cases, the insulation is so thick in that space that it blocks off the ventilation. So that's a an issue that has to be carefully considered and addressed when you have cathedral ceilings. So typical, steep sloped roof, shingle roof, works as a system, not individual parts. So you have, the shingles and the flashing keep the water out. The insulation keeps the house warm in the winter, cool in the summer. The ventilation keeps the airflow and keeps hot air or warm air out of the attic throughout the year. And the ventilation also helps keeping moisture out of the attic, particularly in the winter time. Moisture in the wintertime in an attic can be very problematic because it allows for condensation, which can actually cause leaking into the living space, but also damage to the components of the attic. So this diagram here, this is winter conditions. If you have a properly insulated attic, I'm talking about the left side of this diagram. You have heavy insulation, you have good ventilation, intakes at the bottom of the roof, at the soffits, exhaust at the top part of the roof. The other thing that is important is making sure that any penetrations into the attic are properly sealed. And that, again, as I spoke earlier about vents, such as bathroom vents, are exhausted directly to the outside. You have, a functional attic. You have cool air circulation, no condensation, no moisture, and the attic will function properly. On the right side, if you don't have these things, as I spoke about earlier, you get condensation of moisture in the attic because you have warm air coming up through the ceiling, very cold air outside, the moisture condenses, and it can damage the sheathing and insulation actually drip inside the living space as well. So one of the things that you have to consider is most, if not all of these problems are caused by Mother Nature. And you can't typically get rid of the cause of the problems when the right conditions occur, but we're going to show how you can address some of the potential for problems and minimize problems when they do happen. So I'm going to get into ice damming now. Ice damming is a very specific condition, and it's basically exactly what its name implies. A dam of ice or dams of ice form at the edge of the roof and prevents the melting snow higher up on the roof from draining off. So typically, you cannot have ice damming if there's no snow on the roof, no matter how cold it is. So typically what happens is you get a blanket of snow on the roof and you get a period of below freezing temperatures, particularly, ice dams can occur even if the temperature is below freezing all the time, even in the daytime, but it can be more exacerbated by warmer above freezing temperatures during the day and then below freezing temperatures at night. What happens is the snow blanket acts as an insulator. Even when you have a properly ventilated and insulated attic, the attic is warmer than the outside air. So generally speaking, when you have these conditions, it causes the snow at the bottom of the snow blanket where it contacts the roof to melt. And the the uh, the snow, or the melted snow, and this diagram on this slide will kind of illustrate this. The uh, the snow melt runs down the roof under the snow blanket. When it gets down to the edge of the roof, to the eave, the temperatures there are colder because you don't get as much heat loss down there. And the water refreezes there. And as that happens over time, you get ice buildup at the edge of the roof or an ice dam. The water, as long as there's snow still on the roof, the water will continue to run down, but now it's trapped behind the ice dam. And what happens is it starts to back up under the shingles. And, if you remember, as I said earlier, the shingles work because water runs off of them. They're lapped one on top of the other. They're not really made to have water that runs up the roof or moves up the roof. And they don't really function well in keeping that water out. And so as long as you're feeding with snow on the roof, the water will back up and it starts to get inside the living space. This can be a very difficult problem to deal with because this situation, unlike, say, a leak from a rainstorm where it leaks while it's raining, but once the rain stops, the leak stops. Leaks from ice damming can go on for days as long as the snow blanket keeps feeding more melt water down the roof and gets stuck behind the ice dam. Very frustrating problem to deal with if you have the leak because there's no easy way to get rid of it. And I'll go into that a little bit later, showing some of the ways people try to do that. So clearly, if you have, ice dams and you're getting water penetration, they can cause a lot of damage. As you can see in this slide, the upper left-hand one, you can see the soffit's been disrupted. There's a large amount of ice up in the soffit area. The upper right photo shows damage to a gutter from the weight of the ice accumulating in it. But then the lower photos are where the real problems are, occur from this. You can see that there's deteriorated sheathing as a result of the moisture and water that's penetrating in the lower left. And then obviously the lower right, you can see water damage actually on the inside of a living space. And so you can get quite a bit of damage from this. As I said, this condition can persist for a long period of time, and it's the damages can just keep accumulating. Okay, so typically when you get a snowfall on a roof, it looks like the left-hand diagram there. The roof's covered with snow. Now, in older houses, older buildings that weren't well insulated, you lose so much heat through the roof that it melts the snow very quickly. And although you can get ice dams, because of the amount of heat lost, you lose I'll call it the fuel source for the ice dams pretty quickly. And once there's no more snow melt to run down the roof, what you'll end up with at the bottom there is a completely frozen area. And there's an ice dam, but there's no liquid water continuing to feed it. And so the leaking that occurs, it really doesn't happen. Everything is frozen. next diagram to the right shows what's typically a modern roof. Much less heat loss through the attic space, but enough heat loss to melt the snow underneath the blanket where it touches the roof. And that's, one of the things that, that's the cause of ice damming. And so modern roofs are actually worse with regard to ice damming than older roofs where they're not very well insulated. The larger amounts of insulation that are in modern buildings actually cause more of an issue with ice damming. And that's one of the reasons why ventilating the roof, the attic space, is very important, because the diagram on the far right shows what's called a cold roof. And if you can achieve an attic temperature the same as the outside, you won't get much snow. I'm sorry, you won't get much melting, and you won't get the water running down and then refreezing at the eave and causing the ice dams to start and build up. And that's the goal, a cold roof, but it's not that easy to achieve. And I'll talk a little bit more about that as we go along. All right, so this is today's keyword for CEUs. It is sublimation, and that is the transition of a substance, in this case snow, directly from a solid to a gas without liquefying. And that's what would happen on a cold roof. The snow blanket would evaporate essentially without melting. And that's why you don't get ice dams on a roof like this.
And note, I always forget about the keyword, so that is my fault. I already threw out. You can email me. So don't worry if you send me the keyword now, that's fine. But I know I already sent it and people have emailed me, so don't worry about that. But that is important information either way. So go ahead, John. Sorry.
No problem. So we'll talk about aggravating factors for ice damming. So ice damming can occur whenever the weather conditions are appropriate. However, lack of ventilation or inadequate ventilation definitely is one of the the largest aggravating factor in or allowing ice dams to be a problem. The building code requires a minimum amount of ventilation in an attic space. However, that minimum amount is generally not enough to prevent ice dams. So the minimum code required ventilation does not produce a cold roof. It is what is the minimum required by the code. It will keep condensation and those types of problems from occurring, but it will not keep ice dams from forming. Rule of thumb, you can never have too much ventilation in a roof. So what we're seeing here on the photo on the left, that's an attic fan or ventilator, mechanical device. Generally, and one thing, if you're thinking about installing attic fans, most of them come with a thermostat, so they operate on a thermostat. You want to keep the air temperature, or you want the fan to come on when the air temperature in the attic reaches 95 degrees, say. And the thermostat's set, the fan will come on in the summertime whenever the attic gets to 95 degrees. The problem with that is the fan will never come on in the winter because the attic will never get that warm. So you need to make sure that not only does the fan operate on a thermostat, but also a humidistat, which can be set to a relative humidity. And when the humidity gets beyond that point, the fan comes on, and that will allow the fan to operate during the winter months, when it's cold, whereas a thermostat will not. The photo on the right is showing what's called passive ventilation. So no fans, no mechanics, using the natural like chimney type ventilation where air intakes at the lower part of the roof and is exhausted at the top. Now, the problem with this photo is you have the intakes and the exhaust both in the upper part of the roof. The square vents at the lower, lower part of the photo are the intake vents, and the ridge vent, which is up at the top of the roof there, is the exhaust vent. So when you have them close together like this, the all you get is a circulation in the upper part of the attic, and you're not getting any flow of air at the lower part of the attic. And that's one of the reasons why the building code requires the ventilation to be split between the upper roof and the lower roof. I don't offhand know. Sorry about that. I don't offhand know what the percentage is, but there's percentages in the building code. You have to have a certain percent of the ventilation in the lower part of the roof and a certain percent in the higher upper part. So lack of ventilation is a very big aggravating factor, and also improper attic insulation will also cause problems. If you don't have enough, you allow more heat loss out of the living space, and that can aggravate, the snow melt and the resulting ice dam buildup. Also, if the insulation is, there's voids in the insulation, or it's the attic access hatch is not insulated, things like that, again, allow heat loss into the attic space. You end up with more heat going out the roof and ice dam issues. The photo on the left shows a dryer vent pipe penetrating up from the lower living space through a kind of an oversized chase there. Clearly, that should be closed off and insulated, because you're getting a huge amount of heat loss right up that opening from the heated area below it. Also, if you have flue pipes for your furnace or hot water heater, those should be insulated or protected to minimize the heat loss. Closed dryer vents also, and sometimes you'll have actual mechanical heating and cooling equipment in the attic space that should also be insulated to prevent heat loss and warming of the attic area. Another thing which affects ventilation, the right-hand photo, the green material there, those are what are called ventilation baffles. Typically, when insulation is installed in the attic, it's pushed all the way out to the edge of the attic area. Where those green baffles are in this photo, there are soffit vents below them. So typically, the insulation is covering the soffit vents and obviously eliminating any airflow or minimizing the airflow that comes from there. So the baffles are put in, they compress the insulation down a little, and they allow, because of their shape, they allow the air to flow up from the soffit vents and into the attic, the general attic space, and then out, of course, out the upper part of the roof. So that's the condition on the left is probably not that common, but the condition on the right, where you'll see the insulation all the way out and blocking the soffit vents, that's probably one of the most common things you'll see if you go into building attics. And just an aside, it's also not uncommon to see all of those green baffles piled up on top of the insulation, but not actually installed um, in the soffit area to allow ventilation. So I talked about earlier, condensation in an attic, and clearly it's the result of you have warm, moisture air in the attic space. You have cold and typically drier air on the outside, where those two meet, which would be the underside of the roof sheathing or any roof penetrations. When you have that condition, you'll get condensation. So again, the way you prevent that is having really large amounts of ventilation in the attic space to draw the warmer, moisture air out and not, kind of minimize or eliminate any potential for condensation. And, condensation, I touched on a little bit earlier. You can get all kinds of issues from condensation in the attic. You'll see droplets of moisture on the insulation. You'll see moisture on the sheathing. If it's real cold outside, you'll actually see frost on the underside of the sheathing because of the amount of moisture that's present. You'll also see rusted nails where the nails that penetrate from the shingles through the sheathing. A sure sign of condensation in the attic is you go up in the attic and all the nail penetrations are rusted. When you have a properly ventilated attic, you don't have that. And you can also actually get what people call ringing in the attic, where the moisture is so great that it's dripping off the nail penetrations, it's dripping off the sheathing. And as I said earlier, you can actually get leaking into the living space as a result of that, even though it's not raining or this can occur without snow on the roof as well. So drier vents, bathroom vents, and if you have humidifiers in the house, they all can put moisture into the attic space and cause the condensation issues. So it's important to make sure that the attics are properly and ventilated as much as possible. All right, so I talked earlier about areas that also can be problematic, regardless of the fact of ice damming. And one of the areas is, again, where a roof joins a vertical wall. That's either a side wall or a front wall. The flashing is very important. However, typical step flashing you see in this diagram is 5 inches by 5 inches. So it's bent at 90 degrees. So the piece is actually 10 inches by 7 inches. It's bent in half. 5 inches of it goes up the sidewall, 5 inches down onto the roof. And that's fine. That size flashing is fine when you're protecting from rain. But as you can see in the photo above the diagram, when you have snow buildup on a roof that's very deep, you can actually have the snow be higher than 5 inches, and it's now over the top of the flashing. So if the flashing is not properly counter flashed, and I go back to that earlier diagram with the showing the house wrap or the building paper running over top of the flashing. If that's not done, the snow can back up and get underneath it and behind the flashing, and of course cause a leak into the living space. It can also be a problem even if you have properly installed flashing with the snow above it. It can still manage to get through the flashing and leak. And the other problem area are chimneys where the snow can, I don't have a diagram, but the snow backs up behind the chimney and sits there for a long period of time and can leak in behind there as well. Another area that's a problem, can be a problem, are valleys where two roof planes intersect, and that's a critical area to be properly flashed. Valleys typically, they can use metal flashing, but today that's called an open valley. Most valleys today are called closed. They're either closed cut or woven, and they just rely on the shingles overlapping and preventing moisture from getting in. In this case, this issue, and there you can see there's an ice dam built up at the bottom there, and the arrow is pointing to a diverter that was put in probably to divert rainwater from coming over the edge of the gutter there, because the valley carries a lot of volume of water when it's raining. But in this case, it made the ice buildup problem worse, because you started out essentially with a dam already in place before the ice even formed. So, having a diverter at the bottom of a valley like that can be detrimental to keeping ice dams from occurring. So, I want to talk about some, what I guess people would consider short-term solutions to ice dams. Yeah. Most common thing is people pull the gutters off the building, and that's fine, and that will provide temporary relief, because obviously what typically happens is when you have a gutter, the water runs down, it's refreezing at the bottom. It initially refreezes in the gutter, fills the gutter with ice, and then starts damming up on the roof surface itself. So by pulling the gutter off, you relieve all that ice, and you'll actually see a large amount of water flow off the roof. The problem with that, though, is if the conditions that are causing the ice dam, there's a blanket of snow and freezing temperatures, if they persist, the ice dams will just reform on the roof surface, with or without the gutter. It doesn't require a gutter because the same process goes on. So if you've pretty much lost the snow blanket on the roof, but you're still getting the leaking from what's already accumulated, you can pull the gutter off. That'll drain, and you'll not have your problem anymore. But if there's still snow on the upper part of the roof, you're gonna get reforming of the ice dams. Also, you're gonna pretty much damage all the gutters and potentially the shingles by doing that. So then when you're gonna want to put the gutters back up again at the end of the winter, you're probably going to be talking about a fairly large percentage of having to get new gutters and install them rather than reuse the old ones, because they're very difficult to remove when they're full of ice. They're very heavy, and the aluminum that makes up gutters is not very strong. So in most cases, the gutters get damaged and can't be reused. The other alternative, which is in the photo on the right, is to go up on the roof and remove all the snow. That, particularly on a roof with any kind of slope, is extremely dangerous. And I would not recommend it. And I would not do it personally, but as you can see in this photo, this person is up there removing snow with a snow shovel. The other problem, so, all right, two things. It's not safe. If you don't remove all the snow, you're going to end up with an ice dam higher up the roof. So if you say you don't want to go on the roof, you want to just stand on a ladder and get the snow at the edge of the roof, that's all well and good, but the ice dam will form wherever you couldn't reach to remove the snow. So the only way to make this method effective is to clear all the snow off the roof. And then it almost always, in fact, doing this always results in damage to the shingles. And depending on the care taken by whoever's doing it, that can be minor or it can be quite severe. And again, once the winter's over, all of that damage would have to be repaired. So that's, we don't recommend either one of these methods. If you have a small roof that you can reach from a ladder, maybe you could carefully remove the snow, but for general purposes, this is not recommended. And as I just was speaking about, ice damming will still occur even without gutters. You have the same mechanism at work. Warmer air at the top of the roof melts the snow under the snow blanket. It runs down, and when it gets to the edge, to the eave, whether there's a gutter or not, it will refreeze and cause a dam to form, and then the continuing meltwater will run down and accumulate and work its way inside the living space. So even without gutters, ice dams can still occur. All right, so longer term solutions. You'll see, you might see on roofs what are melting devices, heat cables, different types of systems to try to melt the snow off the edge of the roof or at the eave area. And as you can see in these photos, they actually work. They melt the snow. They're electrical powered. There's issues with those as well. You got to make sure they're operating. I'm sure that in many cases they're manually operated, so you got to turn them on, and then when the snow's melted, you have to turn them off. And if you have a single family home, that might be viable because you're just worrying about your house. But if you have a site that's got 10 or 15 or 20 or 50 buildings on it, somebody's got to be going around and turning on and turning off the heat cables. Otherwise, they're going to operate all the time, and the cost of doing that for an entire winter will be quite large. But they do actually work. The other problem with them is you can get shingle damage down at that lower portion of the roof. They have to be attached. You can see in the upper photo, there's a clip at the upper part of the loop that appears to be attached to the roof. So you're possibly penetrating the shingle. You have to make sure that's sealed, and they also require a lot of maintenance, and they're not that long lasting. So uh, they're not a real good way, but better than pulling the gutters off and sending somebody up on the roof to shovel the snow off. These obviously address the symptoms of ice damming and not the cause. The way to address the cause, and the only real viable long-term solution, is to make the attic space as cold as possible in the winter. And you do that by, you know, minimizing the amount of heat loss into the attic by properly and, putting a lot of insulation in the attic, by making sure that penetrations are sealed, by making sure that any source of warm air is vented to the outside, so kitchen exhausts, bathroom exhausts. Another thing um, that you have to make sure of is where there's recessed lights, particularly what are called can lights installed in the ceiling of the living space right below the attic. Those need to be properly insulated because obviously they generate a lot of heat. So if the recessed can sticks up into the attic space and it's not insulated, there's going to be a huge amount of heat coming out of that when the light's turned on. And so that's where you want to concentrate on keeping the attic spaces as cold as possible. First step is to eliminate as much heat loss as possible. And then the second step is to, uh, add as much ventilation as possible. But also, if you have ducts in the attic, those should be insulated. It's more common today to see what are called flexible ducts, which are insulated. But you also want to make sure that there's no leaks coming out of those, particularly where they join, fittings and so forth, or they're spliced in the attic. Make sure those are taped off so air is not leaking out of those and putting warm air into the attic space. And then, you want to make sure you're insulated. You want to make sure you're ventilated. And also, it's very important, if you're relying on soffit vents as part of the ventilation, that you have baffles out at the edge of the attic space to allow the air from the soffit vents to actually get up into the attic. So that this is the long-term solution. The other things I spoke about are short-term, all have problems. And I'll be honest, even doing this does not eliminate the potential for ice dams, but it minimizes them to a great degree. And then, I'm talking about ventilation and baffles. Mechanical ventilation is also very effective. But as I said, you need to make sure that the fan has a humidistat. And if you see in this slide, it does discuss the code ventilation requirements. So typically in most attics today would be the exception. So you need 1/300th of the area of the attic as far as what's called net free ventilation. And the vents shown in these photos um, if you were considering installing them, they would come with information that tells you how much net free ventilating area they have. The metal vent in the lower right would tell you per vent, it would have X square inches of free area. The ridge vent in the lower left would have it would probably tell you in net free or square inches of free vent area per foot of ridge vent. And then the fan would also have information about how much air it moves per minute, cubic feet of air per minute. So that's you could then determine how many vents you would need based on what they how much air they allow out, and get yourself at least to meet this requirement, that would be the minimum code amount. So as an example, if you go over 1/300, if you have a 300 square foot attic, you're required to have 1 square foot of ventilation area, free ventilation area, which isn't a lot. So it provides a minimal amount, but not enough to help your ice dam situation. So other solutions here too. We talked earlier about where you got potential for leaks. What's pretty common today, and what Kipcon recommends when you're re-roofing a building, that you install membrane flashing at these areas that are shown in this diagram. Depending on the location of your building, the building code actually requires an ice barrier membrane to be installed at the lower part of the roof, at the eaves, where ice dams are the most common place that ice dams form. And they require that it extends 2 feet inside of the wall line of the building. So if you have a large overhang of the roof, that's horizontally. So on a sloped roof, you might need 6 feet of width of the material to be 2 feet inside the vertical wall. And that's a calculation that we would do. If you're going to re-roof the building, we do that calculation to make sure of how much of the ice barrier you actually need. The material typically comes in 3-foot wide rolls. So contractors like just installing, one row of it, because you roll it out and it sticks down and it's easy to do. But sometimes it requires more than that, and you just have to be aware of that. Also, where it runs up against a sidewall, which would be the lower right portion, it's got to run up the wall vertically 6 inches. Now, when Kipcon does roofing specifications, we would put on the sidewall, we would use a 3-foot wide piece and have it run up the sidewall 18 inches and onto the roof 18 inches. And that would eliminate any potential for, if you get snow buildup higher than the step flashing, that it could leak inside. And also valleys, if you put it in a valley, you split the valley, so 18 inches on either side of the valley. The area behind chimneys is also an area that's vulnerable. It's called the cricket behind the chimney. We would expect to put ice and water shield or ice barrier membrane on the entire cricket. So these are areas that you can use this membrane material, which is very effective at keeping water out and water from ice dams, and try to minimize how much damage you occur when you do get ice dams. And yeah, we talked about this. I talked about kick out flashing earlier. That the top diagram shows how you would protect where a roof runs into a front wall. So to summarize, you know, the conditions and the situation I talked about to minimize ice dams also works in the summertime by saving on cooling costs. If you got a lot of insulation and good ventilation, you'll keep the attic area cooler, and that'll reduce the heat penetration into your living space, and therefore help to keep your cooling costs down. And the same thing in the winter. It'll keep your heating costs down, and also for wintertime issues will prevent water, or at least minimize water penetration. So I thank everybody for attending today. If there's any questions, I'd be happy to try to answer them.
I don't see any questions in the chat. A lot of
Yeah.
thank yous.
Okay, well, thanks, everybody. I hope this was informative, and thanks for attending.
And as a reminder, go ahead and shoot me an email. I'll send my email again in the chat just for a couple minutes for everybody to be able to send me one if you have any questions, or if you want your credits. You're gonna get your credits regardless, but for the certificate, you can shoot me an email. So again, thank you everybody for coming. Thank you, John. That was great. And again, this was recorded, so it will be posted to our YouTube page if you would like to ask me for information as well, or just go to our YouTube page within the next day or so. All right. No other questions coming in. All right. Thank you guys so much.
Thanks, everybody.
Have a great day.